we found where some parabola, well, let's be different, and some line intersect. We called that, what's the word, shall we? This point right there, and that point right there, starts with an S. Solution. That's it. That's a solution. Where they cross. How else can I word that? Where the coordinates are the same. Okay? Don't just find X, 2 points for X, and move on. We need coordinates, right? What coordinates does the parabola equal the line? Right there, whatever it is. What coordinates is that point? Right there, right? Okay, so don't forget, we need coordinates here, not just an X or a Y, not half of the coordinate. Same thing, solving a system of, now we don't have a line and a quadratic, we have a quadratic and a quadratic. Okay, exactly the same process. Where do these guys cross? Well, think to yourself, how many possibilities could there be? There, if I got a smiley face and a frown, they cross in 2 spots. Okay, could I have any more than 2, do you think? Just visualize a bunch of parabolas all over the place, just 2 of them. No, that's it. That's the most I could have. What's my other possibilities? Could I have 1 point where they cross? And when I use the word cross, I use it loosely. I mean, they could just touch, right? I could have 1 solution, or could you imagine 2 parabolas that don't touch or cross? Why not? Sure. You can have no solutions, that's fine too. Is that the same as what we had yesterday for choices? Yeah. Okay? So it's very, very similar. You do exactly the same thing. Consider this system. You got to look at that and go, hey, that's a parabola. I got a square there. That's a parabola. Got a square. Are they going to cross? I don't know. You could find out. And if you got, you know the questions say graphically, if you got a graphing calculator, hey, it's good to check. But if you don't worry about it. Okay, I'm just going to ask you algebraically how to do it on the test. If you got a graphing, great, feel free. Just check it. But you still got to do it algebraically. If you just write down 2 coordinate points, guys, I can't give you full marks. Okay? So, what do? Where's this one equal to that one? Or think substitution. This is y. This is also y. So substitute that in for y. It's the same thing. It's the same thinking. Where's that one equal to that one? Substitute it for y. Okay? What works best in your brain? Use it. That's what we do. Okay? Solve this. Trinomial equal trinomials. Just collect like terms. How many x squareds do you have? And you probably want to make this positive. So do I want a minus 6x squared here? No, I want a minus 2x squared there. Subtract 2x squared from both sides. That's what you have. So now I want everything over to the right side, right? Okay, so get rid of minus x, add x to both sides. Get rid of 1, minus 1 to both sides. Okay, that thing is equal to 0. How do I know how to solve that thing? Well, again, you could graph this and find the zeros, or if it factors, you want to factor it. If it doesn't factor, use quadratic formula. Okay? Is there something that multiplies to negative 5 times 4 and adds to 8? 10 and 2 multiply to 20, but I need a minus here. That's got to be plus. So put it on the smaller one. Then double check it. Okay? Some of you guys are still like doing all this work and you got it wrong right off the bat. Does that work? Does it multiply negative 20? Yes. Does it add to 8? Yes. Split up 8x into 10x minus 2x. Okay, everything else stays the same. Let's put the 0 over here. Then you check. Is that the same thing? Double check it. 10x minus 2x, that's 8x. Yes, it is. Okay? Don't make a mistake here, guys. Okay, check it. What can I factor out of the first two? I can take a 2 out. I can take an x out too. That leaves me 2x plus 5. What can I factor out of here? Not much. But if I take a minus 1 out, I'm left with 2x plus 5 equals 0. So factor out 2x plus 5. What do you got left? 2x minus 1. Okay. When's this thing equal to 0? What value of x here is going to make this thing equal to 0? Let's go here. So x is minus 5 over 2. If you don't see that, guys, what do? You let this thing be equal to 0 and you solve it. Okay, minus 5 to both sides, divide by 2. Okay, right? But most of us are getting kind of good at this. That's one thing. When is this going to be equal to 0? When x is positive a half. And then check it. Like substitute it back in. Does that make this equal to 0? Because on the last test, a couple of you made this mistake and you lost an easy half a mark, right? And if the thing's only out of 17, what is half a mark out of 17? Just by making some silly mistake because you didn't check it. Like about 3% of your test, right? You missed because you didn't check. You've got the wrong sign here. You didn't put it back in to check it, okay? If I put minus 5 over 2 here, is that 0? Yes. Negative 5 plus 5 is 0. If I put a half here, yes. Okay, check, guys. Check, check, check. That's my x's. Is that my total solution? No. That's just the x coordinates of the solution. How do you know where y is? You got to plug it back in either one of these equations. Okay? Which one looks nicer? Probably the second one. Okay? So if x is minus 5 over 2, I got 2x squared minus x plus 1. Okay? And guess who, when doing this, won't put a minus here? Probably about 10 to 15% of you. Right? Use brackets when you substitute. Okay? And then you're less likely to make mistakes. So 2 times, that's 25 over 4 plus 5 over 2 plus 1. What's that? 25 over 2 and 5 over 2 and 2 over 2, which is how many things over 2? 32 over 2, which is 16. Right? Carpenter wouldn't do it like that, but I divided that in there. Yeah. Okay? Or 50 over 4, which is 25 over 2. Okay? Yeah, I'm kind of whipping through it a bit, right? I know we all love fractions. Okay? So one of the solutions is negative 5 over 2, 16. Okay? Plug the other one back in, get the other one. You know how to do that. You should get 1. That one looks out nicer. Okay? That's the solution. You should verify. If it were me on my test, I would. But I'm not going to do that here. Okay? All right? That's the two places where that parabola crosses this parabola. Okay? I don't even know what it looks like and I don't care. That's where the solutions are. Okay? So same as yesterday, only got another parabola. Flip on over to 5:15. Because what does that word say there on Tuesday? Inequality. You haven't even seen one yet. How can I call it an inequality test when you don't have an inequality? Those have all been equalities. Oh, yeah, this stuff. Okay. Inequalities. It's not going to be that bad. Okay, let's just flip right on over to here, 5:16. That's an inequality. We've been doing this for months, right? Okay, where x is less than 2, where y is greater than or equal to minus a half. Okay, it's not new, but we just got to solve it. Okay, so what do? These are inequalities. You can have, here's your 4 choices, right? For inequalities. This is an equality, but there's also an equal in here, and there's an equal in here, okay? What does this say? That says greater than or equal to. This one says less than or equal to. That kind of makes like an L. That's one way to remember it, okay? That just says greater than, not equal to. That says less than, right? Okay, that's your 4 choices for an inequality. When is that greater than or equal to 6? That's what it says. When we do this and find the solution, there's going to be lots and lots of points, not just one point. Okay, so how we do that is we shade the whole area. Okay? If we're doing equal, we're going to use a solid line, and if it's not equal, then we're going to use a dotted line. Okay, you'll see in a sec what I'm talking about. Graphing without using technology. Okay, so steps, here they are. On a coordinate plane, where's my yellow? Okay, just graph the linear equation. So ignore the inequality. You got to know where the line is. Okay? How do you know what side? What am I trying to say in English? How do you know what side of the line to shade if you don't know where the line is? So first step, this says just graph the line. Okay? You can use a table of values. Like I said, you can always do that. Go back to grade 8. X, Y, grid, the whole thing. It's probably quicker to do slope y-intercept form. Okay? Or you could just find your x and your y-intercept. How many points do you need to do a line? Just 2. Okay? There's lots of ways to graph a line. That's the first step. Second step, all this says is, what side do you shade? Here's how we do this. We just use a test point. We test one point and see if it works in the inequality. If it does, that's the side we shade. And if it doesn't, then we shade the other side. Step 3, shade. Okay, this isn't art. Don't spend all day doing that. Here's how you shade. Done. Okay? All right. Graph this inequality on the grid. Could I come up with a simpler one to start? Probably not. Okay, what's step 1? Just graph the line y equals x. We're going to shade the solution side of the line, but you got to know where the line is. Does everybody know where that line is? Shelby, does Dan know where this line is? I don't know. Can you ask him? Can you ask him? No? What was the answer? No? Okay, again, how do you graph this? You can use a table of values. Okay, let's do it. X and Y. This is your go-to points. I want to know what's happening around the origin. Okay, if X is minus 2, put it in the equation. What's Y? Lewis? You're staring right at me, but you're just like brain somewhere else, right? If X is minus 2, substitute it. What's Y? Will, help him out. Hey, there it is. If X is minus 1, Y is the same thing. Hey, look, the same thing, the same thing. If X is 0, Y is 0. If X is 1, Y is 1. If X is 2, Y is 2. If X is negative 1, Y is negative 1, and so on and so on and so on. This equation says X is Y. Whatever X is, that's what Y is. That's this 45-degree angle. Okay? You like slope, Y equals mx plus b? Then you're going to do this. Y equals mx plus b. My y-intercept is 0. I got 1 unit of rise, 1 unit of run. Same thing, right, guys? Okay? Either way. If you've memorized what the line y equals x is, then you've already got an advantage, don't you? Okay, step 2. Do I dot it? Or is it solid? We make it solid if it's equal to. We dot it if it's not equal, if it's less than or greater than. Is this thing equal to, or just greater than or equal or less than? It's just greater than. Why don't we want to make this thing solid? Because, Mr. Watson, a point on that line is not a solution. Okay? Let's look at this point right here. That's on the line. That's 2, 2. If I put 2, 2 in here, is 2 greater than 2, Danny? It's not. It doesn't work. So this line is not a solution. That's why we got it. Okay? Any point on this line, 0, 0. Is 0 greater than 0? That's incorrect. 0 is equal to 0. Okay? Now, where's the solution area? Step 3. Shade solution side by using a test point. Let's try a point. Let's see if it works. What's your favorite point today, Reese? -2 and 2. Reese wants to use this point right here. Let's try it. Test -2 and 2. Okay, now careful, because x is -2. That's the second thing here. Y is 2. That's the first thing. You see how it's kind of opposite there? So y, is that greater than -2? Yeah. It works. So I'm going to shade that side. Okay? Yes. Okay, so shade the side where that point is. Let's try another point, just because it's our first one. And we're inequality rookies. Let's say Reese liked 5, 0. Okay? I want to test that point. I already know it's not in the solution area, right? But let's see. Does that work? Test 5, 0. Y is 0. Is that greater than x 5? No. So if that's the one I tested, that's not the solution area. I'm going to shade the other side of the line. Okay? Now, how many choices do you have for test points? Infinite. Use one that's nice. What's the nicest point you could possibly test? The origin. 0, 0. But in this case, that's not going to help you because it's right on the line. Okay? Wow.
So how do you know what's right? Like, if that point was right and it's shaded that side, but what if another person shaded the other side? Like,
Then they would get it wrong.
I
You
know what-
shade, okay, hang on. You shade the solution side. You don't shade the side that isn't solution. Okay? So, try minus 5, 0. Why is 0? Is 0 greater than negative 5? Yes, it is. That's also solutionary. Any point in here is going to work in this equation. Right? Any point you can think of here is going to work. Every point here is not going to work. Okay?
So if they, yeah, I know.
Okay. You shade the solution side. Right? We could have shaded the non-solution side, but let's be consistent, right? And thankfully most books are. Because if you go to look at some other resource, I don't know what I'm doing, I'm going to check this textbook. Well, if they did something different, hey, that reminds me, remember algebra tiles in grade 10? My book did one thing and the government exam did the exact opposite. Like, is that screwy or what, right? We don't really have a convention. With this, we do. Okay, we shade the solution side. Okay, let's look at another one. What's step 1? Where's this line? Before I can shade the solution side, like, I got to know where the line is, right? Okay. Do you want to do y equals mx plus b? Do you want to do an x and a y table? I'm going to do intercepts. If you want to do it your own way, feel free. Okay? The x-intercept, what happens at the x-intercept? Y is 0. Write it. Okay, y is 0. Substitute it in. 3x minus 0 equals negative 6. Okay? Did I emphasize that? I just want to know where the line is. Don't worry about the inequality. Let's just find where the line is. Okay? Solve that thing for my x-intercept, and it looks like my x-intercept is minus 2. That's right there. So far, so good? What's the other point I want to find, Shoni? Yeah, what happens at the y-intercept, Shoni? Does it like always happen like that? Or is this just this time? I think you're right. X is 0. 0 minus 2y is equal to minus 6. Divide by negative 2. My y-intercept is 3. How many points, Jade, do I need to draw a line? That's right. Do I make my line solid or dotted, Brenna? Sorry? Equal to, solid, yes. So this line is part of the solution. I'm going to make it solid, okay? Now, you probably want to do a ruler, depending, but you know what? Good enough. I just want to shade either the top or the bottom. How do I find out what side to shade? Terrenay, what do I do? What is step 3? Sorry? Yeah. How do I know what side to shade here? I'm almost done. Here's a test point. What's your favorite test point? Okay, let me repeat that again. What's the nicest point you could possibly use? Like, do you want to use, I don't know, let's use 5.5 and negative 2 3/4. Would that be a smart thing to do? Can I use this point? Then use it. Is 0 minus 0 less than or equal to negative 6? Is 0 less than or equal to negative 6? No, it's greater than minus 6. No, so I'm going to shade the other side. That's not part of the solution. This doesn't work. Okay? No. Shade other side of the line. Okay? Good enough. Done. Do we want to check another point just to make sure? Yes, why not? You got to find one over here. You can't get one too close to the line. Like, don't do this one. I'm not positive that's on this side of the line or not. Let's make sure. Let's go minus I don't know, minus 5 and, how about just minus 5 and 0? Are we sure that's on the other side of the line? It better work then, right? So minus 5, 0, plug it in, is 3 times minus 5 minus 0 less than or equal to minus 6? Is minus 15 smaller than negative 6? Yeah, I'd rather owe $6 than $15. Yes. Okay, it works. I double checked it. Okay? If you want to try to memorize that, it might be helpful, but what I've just shown you will work 100% of the time. Okay? Why try to find a shortcut? By the way, do you know how to plug these in your graphing calculator? I'm not keen on showing you because usually people screw it up anyway. Okay? Should I do this one or not? Are we pretty good with our lines? Do we remember this stuff from grade 10? All right. What if we're going backwards? What if you don't have the equation of the line, but you're given the picture? Do you think you can find the equation of that line? What do we know about this thing? It's given the two intercepts, isn't it? Can we find the slope if you're given 2 points? Okay, or what's the rise over the run here? Rise is 1, 2, 3, 4, 5. My run is, can we count there? What is that? Must be a 2, right? 1, 2. Is it a positive or a negative slope? It's positive. Okay, because all the lines that look like this tilt to the right are positive. All the ones that tilt to the left are negative. Okay? That's how I would do it. That's the slope. We want to write an equation in this form. Y is mx plus b. All I need is the y-intercept, and I'm done. What's the y-intercept? Oh, look, it's right there. Okay? Where x is 0, that's the y-intercept. So there's the equation of the boundary line. If I'm writing an inequality, do I want to have an equal in there? Yes. Did I count 5? Oh, well, I'm stupid. So 4. 1, 2, 3, 4. There. Why did I get another line in there? I don't know. Yeah, thanks. Okay, that's better. It's obviously not 5. That's there. Okay. Maybe counting wouldn't be a good way to do it. Okay. Another good question. Was that part of my equal sign? I don't know. Okay. Whipping through it. Okay, guys, when you want to do this, you want to do it the right way, okay? Not the wrong way. Okay, that looks better. So that might be the equation for the line, if all things are well. When we're trying to make the inequality, that's a solid line, right? So either, well, you got two choices. It's this, or it's that. Is it all y values less than that line, or is it y values greater than it? Use a test point. Choose one of these, plug that in, and see if it works. Let's try this one, okay? Is 0 less than or equal to 0 plus 4? Yes, it is. So that must be it. Okay? So kind of going backwards. Okay, using the points, plug it in. Yeah, you get 2. Okay. All right, there's your questions. I might say a little bit, itty bitty stuff on Monday, and I might not. Okay, it might just be full review day. This quiz on Tuesday, I might give you something else.